several misconceptions, right? Many a times the students get confused and they think of heat and temperature as the same thing, while both are different thing, right? No, so we know
Yes,
that
sir.
like heat is a form of energy. Heat is a form of energy, while temperature is the measure of coolness or hotness of a body,
Yes, sir.
right? And then there's another misconception also, like transfer of heat from one body to another always needs a medium. Transfer of heat from one body to another
Another
always
body.
needs a medium, but that is not always true. For example, we have case of radiation. So radiation of
Yes.
it does not requires any physical medium. What example do we have of radiation?
Of
Yes.
radiation. Yes, sir.
Yeah. What is the example of radiation?
Mm,
Hmm. Like the heat that is coming from the sun. Yeah.
uh,
Heat heat that is coming from the sun, that is an example of radiation, right? Now, and heat, it is coming from space basically, right? Sun is in the space where there is no medium, it is basically vacuum. So vacuum is not a medium, right? No, since vacuum doesn't have any particles, so it's not a medium. किसी भी medium होने के लिए उस medium में particles होने चाहिए. There has to be particles found in the medium, right? Now, but vacuum, since
yes.
it's not having any of the particles, thereby it's a vacuum, right?
Yes,
Now,
sir.
it's not a physical medium. So heat is traveling from the sun, okay, via the radiation, right? Okay, then there's another misconception also. Okay, yeah, Tehseen, have you joined? Assalamu alaikum. Yeah. Okay, did you guys receive the class link late today?
Sorry, sir.
You guys
Sir,
received the, yeah,
I didn't receive the class link. That's why
class
Sir,
link
I
on
received.
time.
I didn't receive. Sir, on time. Always they
Class
give
link
before
on time
class.
today.
Sir, you can give
Okay.
us 10 minutes extra class.
Uh, Actually, I can't because when this class will end, another class will start. Okay ना.
Okay.
So if
Another class.
अगर ये हमारी last class होती ना, अगर ये मेरी आज last class होती, I would have taken 10 minutes extra. Anyways, okay.
Okay.
Sometimes this problem happens. No need to worry that much. Anyways, then there was another misconception regarding heat also. Okay, Tehseen and Abdul, like boiling water causes more damage. Boiling
Oiling,
water
sir. Oiling
causes more
water.
damage. So
He's
boiling
talking
water.
about the land breeze and sea breeze.
Hmm. No, I'm talking about a misconception. Some of the misconceptions that are there regarding to heat. Like people say, like boiling water causes more damage, but that is not true. That is
Yes, sir.
false now. Steam causes more damage. Steam causes more damage right now
Steam, yes, sir.
because steam has
Yes.
got more energy than the boiling water, right? Okay. So far, just to have a brief of what we have discussed, we discussed the concept of heat, how heat travels from one body to another, what is basically temperature. Can you guys name the scales of different temperatures?
Celsius, Fahrenheit, and Kelvin.
Kelvin, very good. These were the three important scales. What were the two thermometers which we use, in which mercury is also used?
Yes,
Sir?
sir.
Name two types of thermometers in which mercury is used.
Thermometer.
Sir, the bulb of the digital thermometer is made of mercury,
Mm-hmm.
and for the reading, mercury is present in the clinical thermometer.
Okay, as well as in the laboratory thermometer also, no? Yes. In the
Yeah.
laboratory thermometer also, mercury is used now.
Oh.
In a laboratory thermometer also, mercury is used right now. So you have got two such thermometers in which mercury is used. Okay.
Yes, sir.
Okay, will you guys be able to differentiate between what is heat and what is temperature? If I were to ask you guys to differentiate between the two, like what is heat and what is temperature?
Sir, temperature is the degree of hotness to coldness.
Mm-hmm.
Heat is a source of energy.
Not source, it's a form of energy.
The
Form
form of
of
energy.
energy, right? When you say source of heat, na source of heat basically mean a body that is basically burning. That will be source of heat, and temperature is basically degree.
Sir,
Mm-hmm.
heat refers the amount of energy in an object.
Yeah, and we can look at it in this manner also, no guys. Like heat is the cause. Heat is the cause which gives rise to temperature. Temperature, we can say it's the effect. Temperature is effect, right? Like if I were to hammer a piece of wood, एक piece of wood को मैंने hammering किया, I have hammered a piece of wood, it will break into pieces. So here the breaking of pieces is the effect, while the cause of it is hammering. Okay.
Sir, in
Hmm.
the heat, it is measured in ounce or calories, and
Hmm.
in and in temperature, there are
Hmm.
degrees such as Celsius, Fahrenheit, and
Hmm.
Kelvin.
Good. But you guys missed one point here. Abdul and Tehsil, look here. The unit which you told me, na, it's a CGS system unit. The calorie that you were telling me, that's a CGS unit. In terms of SI unit, by the way, I told you guys what is the unit of heat. SI unit of heat is
SI unit of which degree?
heat, basically for heat. Not in terms of scale. Here we are not talking about in terms of different scales. Scales are for temperature. Kelvin, Celsius, Fahrenheit, that is a different thing. If I were to talk about heat as a form of energy, in which unit we measure it?
Sir, Joules,
Joule,
Joule.
Joule, Joule. Joule
Joule.
or joules, basically,
Yes,
represented
Joule.
as capital J. Yeah,
Yes.
right now, guys. And SI unit of temperature, it is actually
Sir, I
Kelvin.
thought that J is silent.
No, 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 no. It's a joule. It's pronounced as joule.
I
While
was
for
telling an
temperature,
ounce because I thought it was.
नहीं 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 Tehsin, J is not silent over here. Okay now. Okay, and then for temperature, it's Kelvin. Neither not Celsius and not Fahrenheit. Remember, it's Kelvin, right? Okay, okay. By the way, can you guys tell me, like, why do we use mercury in the thermometer? What were the reasons for using mercury in thermometer? Quickly, first one is the reason for using mercury in clinical thermometer. First one is it expands.
Sir, it's to check the reading of the temperature.
Yeah, to check the to check the reading, to get the reading. So that reading we are able to get because of the expansion, no? So we see that it
Yes.
expands evenly. It expands evenly as the temperature rises. It expands in an even manner, right? No, like
Yes.
where I told you guys, no, even if we were to take a reading of 10 persons, if I were to
Yes.
use a clinical thermometer to take reading of 10 persons, and suppose everyone is having a body temperature of 37 degrees Celsius, so the manner in which the mercury will be expanding inside the clinical thermometer will be even for each of these persons. Getting at what I'm to say?
Yes, sir.
ऐसा
Yes,
नहीं
sir.
होगा कि like one person who is having body temperature 37 degrees Celsius, actual में इसकी body temperature is 37 degrees Celsius, but the thermometer will show 37. Then for the second person, it will show 36 degrees Celsius. No, it's not like that.
Oh,
Mercury
yes.
expands in an even manner. Then other reason. for using it is that it does not stick to the
Tube. It does not stick to the glass. Glass.
exactly not sticks to the glass tube basically, right? All right then. By the way, I hope you guys remember the different scales.
Yes, it
By the
is.
way, Tessin, you told me like the different conversion scales of temperature from one unit to another haven't been taught you in the school.
So
Yeah, yeah.
I can after the laboratory thermometer, everything is cancelled for us, including conversions.
Okay, okay. So your school is following, by the way, which pattern? Is it the CBSE or different pattern?
So
Your school follows CBSE pattern, or is it the ICSE pattern, or is it
no,
having a
sir. We follow the
Hmm,
CBSE pattern.
you follow the CBSE pattern? Okay. And Abdul, आपके लिए भी
Yes.
CBSE pattern follow होती है आपके स्कूल में भी?
CBSE. Yes, sir.
Okay. Anyways, but still no, it's I would recommend like if you guys get some extra time, or if you guys are like interested to in future, you guys will be needing these formulas. Even you Tehsin will be requiring. So for the chapter, it's up to you. जब आप exam की preparation करेंगे, at that time you can leave it. But now it's better to keep them in mind as well. Okay, no?
Yes, sir.
Right. Okay, and then we did talk about conduction. We talked about convection. Now we will be talking a little bit about radiation, but before that, I actually need you guys to have a look at this thing. Look over here.
Yes, sir.
Hmm. Utility of thermal expansion. Okay.
Sir, what does it mean? Thermal expansion.
Thermal expansion. Okay. Thermal. Therm basically means what? Here, Tehsin and Abdul, therm basically means this word, THERM, therm. It basically means heat.
Heat.
Okay.
Yes, sir.
Expansion, both of you know what expansion is, right? So
Yes,
look,
sir.
whenever I will be heating a body, okay, whenever I will be heating a body, and due to heating, if the size increases, then that is said to be thermal expansion, right? So
Right, sir.
the increase in the size of an object on heating is called as thermal expansion.
Yes,
Okay.
sir.
Okay, sir.
And
That
this
means,
thermal Mhm,
sir, that means when we heat any body, we
mhm.
call to the thermal expansion.
Yeah, we say that the body expands in its size. Okay, now
Yes.
the body expands in its size. Thereby, it's called as thermal expansion. So, thermal
Yes.
expansion, we can see it in all the three forms of states. Whether we talk about solids, right now, whether we talk about liquids, or whether we talk about gases, right now. So in all three states, thermal expansion can be seen. Out of the three, which one will expand more upon heating?
Liquid, sir.
No, no. Tessin,
The
Solid.
gaseous form.
gases, exactly. Right now, gases, because the particles of gases now are already
Provide heat.
free. Right now, they are already free. Like
And sir,
suppose we, Mhm.
sir, I think they provide also heat.
Here, that is another discussion. I right now I'm seeing here about expansion here. Right now, so when I heat air also, that also expands in different directions. So since the molecules of air are free to move in any direction, thereby the expansion will be much in the gaseous medium. Talking about expansion of the solids, look at some of the images over here. What do you guys think, like why the electric wires are hung loosely, why they are not hung very tightly, not tightly? What do you guys think? Hmm?
What is so?
Look over the image number one over here. These electrical wires that you see over here, they are not hung tightly. tautly, or basically they are not very much stretched. They are not hung tightly. Why is it so, guys? Because what do I know? That upon heating, a solid substance will expand. Now, this wire being a solid substance, it will expand. So, had the wires been like this, had the wires been like this, then what will happen? In the summer season, they are already very tightly stretched. If it were to be tightly stretched like this, then the wires will try to expand. They will try to pull apart each other, and then they will simply break from the middle or from anywhere. Getting it now? Both of you are you guys getting it or not?
Yes, sir.
Can you just more?
You're Tehsin? Okay.
Can you just explain
And
once
then
more?
like, yeah, sure. Look over here. What happens? We know that solids, liquids, and gases will expand on heating, right? Now, so suppose there are two poles, electrical poles, and I need to hang a wire between them. So uh, um should I hung the wire like this, or should I hung the wire like this? Look here. Suppose it's the summer season now. This is summer, right? So we know that solids will expand. So if this will expand, suppose you are not having a rubber band. Suppose you are having a rubber band. Yeah. So when you expand, what does happen basically? It stretches and becomes straight now. Yeah.
So,
It stretches and becomes acquires a straight shape. Same is the case with this electrical wire also. So basically, during the summer season, it will be stretched in both the directions, right now. And if heat is too much, then the expansion, then the stretching will be too much, and thereby the wire will break. Wire will break. That's why we hung it a little bit loose so that we allow the space for expansion. I hope you guys are able to get it. Yeah.
yes, sir, I got
Is
it
it
now.
clear now? Right. And actually, thermal expansion is a good thing in some cases. Guys, for some of the you have actually got applications of thermal expansions of solids, right? Like
Yes,
for
sir.
example, have a look at this iron rim placed over the wooden wheel. Okay, have you guys ever rode over a tanga, or what do we call it, this, the cart pulled by the bullocks, huh? Cart pulled by the oxen. Have you guys ever rode that on villages? Usually it's found in the villages. Anyways, what I was trying to say over here, that this iron rim is placed over this wooden wheel. I don't know if you guys can see it or not. Look over here. This is actually iron
Yes,
rim
sir. We can see.
placed over it. You guys can see it now,
It's
right?
rusting.
Yeah, it's has actually rusted. That's why we are not able to see it properly. So there's an iron rim placed over it. What do you guys think? How do they fit the iron rim over this wooden wheel? Actually, the thing is now, this iron rim now, this iron rim is made slightly smaller than the diameter of the wooden wheel. Okay, whatever is the diameter of this wooden wheel, whatever would be
Sir,
the diameter of this iron rim is smaller than the diameter
your
of the
sound
wooden
is
wheel.
not coming, sir.
Yeah, am I audible now?
Yes, sir. Yes, sir. I already got
Yeah.
it.
Okay. So guys, listen to what I'm saying very carefully. The diameter of this iron rim will be made slightly smaller than the diameter of this wooden wheel. That point is clear?
Yes,
That point
sir.
is clear now? Now, what will happen in order to fit this smaller
Yes, sir. Yes.
iron rim
Yes, sir.
over
Yes.
this wooden wheel? We will heat it. हम इसे heat करेंगे. We will be heating this. So thereby due to heat, it will start to expand now. Its size will increase, है ना?
Yes.
Right?
Yes,
Now
sir.
we will place it around this wooden wheel, right now. So the iron rim is heated, and this hot iron rim will now be placed on the wooden wheel. And now once we have placed this hot iron rim over the wooden wheel. Now we will
Sir,
cool
your
it
sound is
using
not coming
water.
again.
Yeah, guys, am I audible now?
Sir,
Hello.
you're audible.
Okay, okay. I'm audible to you, Tahsin, continuously, no?
Yes, sir, you're audible.
Okay, okay. Okay, I guess Abdul, you are having connection issues from
Sir,
your side.
again.
Abdul, I think you are having connection issues from your side, because from my side it's clear. Okay. Yeah. And it's usually instructed to every student in the class, please do sit in a quiet place in your, or basically have us in your study room. It would be, it's better actually. Okay. So basically what I was saying, that this hot iron rim will be placed over this wooden wheel, and then we will pour water over it. Thereby it will cool down and then contract. Yes, Abdul and Tahsin, getting it now? Now it will start to contract.
Yes, sir.
Thereby
So
it
can
will
you
be,
explain it again? I couldn't understand properly.
look over here. Look over here. Hmm. Say this is the wooden wheel, right?
Yes, sir.
And this is the iron rim that we need to place over it. So actually this iron, the diameter of this iron rim will be smaller than the diameter of this wooden wheel, right? So first what we will do, we will be heating this. We will heat this. So first step is heat the iron rim. There will, it will expand. Once you have expanded, now you will place it over the wooden wheel. You will place it, right? And then in the third step, you will cool it down, cool it using water. So thereby it will contract now. Its size will shrink. Thereby it will be tightly fitted over the this wooden wheel. Getting it now? This is how basically iron rims are fitted on the wooden wheels. So that is an application. Also, many times you must have seen, like, to if there's a uh, stuck stopper or cap from a bottle. Right now, say there's a bottle in which the stopper is stuck. This stopper is stuck. So for that, what do? We pour hot water over the neck of this bottle to remove the stuck stopper in it. Yeah, you might have actually seen your mother doing actually pouring hot water over it in order to remove the stopper from here,
Yes, sir.
right now. And then there was example of this rail racks as well, right? So look over here, this rail rack has actually, its shapes has actually distorted, it has actually bent, right now. So it was trying to expand but didn't had enough space to expand, thereby it
Yes,
bent
sir.
like this right now. And if it were to continue be exposed to heat, then it will break basically, it might break from somewhere. So thereby what do? We need to provide some spaces, right? So in the Indian railways, especially when you travel, you get to see at places there are spaces left between the tracks right now, so that when they expand, they do not bend like this iron rail track. Hope it is clear. Okay.
Yes, sir.
Yes,
All
sir.
right. Now back to what we were discussing. We were discussing about transmission of heats, right? Now this is what we have been discussing all the while in the class. So far we did talked about conduction, convection, and right now we will be talking a little bit more about radiation. Please, you both of you tell me, do you have any confusions in regard to conduction and convection? Yeah. Any confusions in conduction and convection? Please do ask me.
No, 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 sir, no confusion.
No, sir.
Okay.
Just little, can you like explain it a little bit? Convection, little bit only.
Convection. Okay, but before conduction, now let's talk about a bit about conduction. Conduction. So I guess both of you can answer this to me. Like, you guys tell me, like, heat can be conducted from one body to another by the process of conduction, only if the two bodies are in. My question is that heat can transfer from one body to another by the
Another, yes.
process of conduction. So, for heat to pass from one body to another via the process of conduction, what are the conditions required?
Sir, can you repeat it again?
Uh,
Yeah. My question is
what,
that,
sir?
please turn your mic off. This
Sir?
background noise. If someone's mic is on and there's background noise, please turn it off. Yeah. My question was that in order for heat to travel from body A to body B, why the process of conduction? What are the conditions required? Now you guys can answer. Let's start from Tehsin you.
Transfer of heat.
Yeah. From body A to body B, why the process of conduction? What
Sir,
conditions do we require?
um, sir, we require to take something aluminum or copper because they are good
Hmm?
conductors.
Okay, good. So we need good conductors. Then second, okay.
Sir, we
Abdul,
have to
you?
avoid
Okay, that's.
using bad
Hmm.
conductors such as the plastic handles. They keep the plastic handles at the pans so that the heat is transfer and make it hot.
Oh, that's a different thing. That's the utility of a insulator. That's the utility of
Sir, your
insulator in order
voice
to.
is lagging.
Yeah, Tehsin, is my voice breaking for you also?
Sir, no, it's not lagging that much. It's
Sir,
very
Okay.
like just for me, but now it's okay.
Okay. Is it clear to both of you now?
yes,
Yes, sir.
sir.
Okay. Okay. Now, I'm actually asking you, what are the conditions required? Notice the word over here, condition required. Like they have to be good conductors. You guys are missing one very important thing over here.
I'm sir, solid. It should be a solid substance.
Solid substance, good. Solid and in contact with each other. The basic thing you guys are missing over here. Conduction, the flow of heat by conduction will only take place while it's a solid medium and they are in contact with each other. Yeah, right now, Abdul. Right, Tahsin. Now we come to the third condition required. Like, say there are two bodies, body number A and body number B, and both of them are having equal temperature. Yeah, Abdul, both of them are having equal temperature. Will there be flow of heat between the two bodies?
Mm,
Obviously, no,
no, sir.
right? So, Tahsin, next we require different temperatures now. Yeah, we
Sir,
require
your voice is lagging between.
yeah. Am I audible now? Yeah. So I'm saying different temperatures. The two bodies needs to have different temperature because what do we know? That heat travels from a hotter body to a colder body.
Yes, sir.
Okay, right.
Yes.
Now with this, I will be moving ahead now. Now in the case of convection current, now let me repeat as Tessin
Yes,
was
sir.
asking me, like what is convection current, and please repeat that. So convection basically it was the mode of transfer of heat in liquids and in gases. Right now,
Your voice is stopping between.
okay. Yep.
Sir, you're not stopping for me. You're not lagging.
Okay. Please let me just check that. Okay.
Sir, maybe
I'm audible to
there's
you,
a
not Tessin?
network problem in Abdul's
Yeah.
house.
Yeah. Exactly. I think that's the issue. Abdul. Yeah. Am I audible to you now?
Yes, sir. Now you're audible.
Uh, Actually, so, since it's not lagging for Tehsin, it's likely that you are having network issues now. Okay, so please do get
Again,
fixed
sir.
that. Abdul, it's not lacking for Tehseen. I think you are having network issues. So I will be continuing from convection.
No,
Look over.
sir. No.
It's not coming to you. Okay, maybe sit in a different room. Maybe that will work.
Near the network.
Yeah. So convection, we did talk like it's a transfer of heat in which there was actual movement of particles, right? No? So there was actual movement of molecules of the liquid and gaseous medium from one part to another, right? And for convection, actually we require medium. We do require medium. For conduction also we were requiring medium, right? And for convection also we require medium. For both of these we require medium. And then we had the concept of convection currents also. Okay, so we did talk about the concept of convection currents. Look over here. This circling of water molecules that you see over here, that is actually
Yes.
convection currents generated in the water.
Yes.
Same type of convection currents are generated in the air also, right, Tasin and Abdul?
Yes, sir.
Yes, sir.
So, so convection in the case of air, you had two concepts of land breeze and then the sea breeze, right? So in the sea breeze, there was flow of air from sea towards the land. So look over here. During the daytime, what happens? During the daytimes, look
So
over
during
the
the
sim.
daytime,
Mhm,
the land heats up faster and it
mhm,
also cools down faster. And in
mhm,
the daytime, the cool
mhm,
exchanges to the hot. It transfers cool
mhm,
to hotness in the water.
mhm. Very good, right? So that is actually sea breeze during the daytime, right? So during the daytime, there will be
Yes, sir.
flow of gentle winds from the ocean towards the land surfaces, right? And then we had the concept of pressure difference between the two, right? Now, like I told you, like air always blows from a high pressure region to a low pressure region, right? Now, so thereby on the land side, it's a low pressure region, right? During the daytime, right, Abdul and Tahsin? And on the water
Yes,
side,
sir.
there's a high
Yes, sir.
pressure. So from high pressure to low pressure, flow of air take place. And then just the opposite happens during the night time when we call it to be land breeze. हम कहते हैं. So in the land breeze, the pressure over the land surface is now higher, while on the water surface, above the water surface, it's lower. So air moves from land towards the ocean. So that was the
Yes.
concept of land breeze during the night. Okay. Now let's continue with the radiation. In fact, we did actually discuss about radiation. Okay. Also, please, you guys do not forget about the practical applications of radiation and convection. Can I ask what is a practical application of convection?
Yes, sir.
Yes,
Sure.
sir.
Hmm?
Sorry, sir.
Yeah, practical application of convection currents. Yeah, in our house, where do we get to see the practical application of convection currents? Simply convection हम कहाँ पे देखते हैं that concept being applied in our house as well. Yeah, Abdul, you
Yes, sir.
in
Sir,
our
near
house.
light switches.
Yes,
Yes, sir.
Light switches. Near light switches.
near light,
Light switches.
near light switches. Near light switches specifically mention the thing you are trying to say.
Yes, sir.
Look, guys, you had all these diagrams. I had all these diagrams for you guys. Look over here. This this inner view of a room over here. What do we see from here? Like where is the ventilators
See the
placed?
radiation of fire going in the house.
Yeah, radiation, don't look at the radiation right now. Right now, let's only get a second with the concept of convection right now. Okay, so look over here. This red arrows are representing the hot air that are rising above. Right now, this is the fireplace in the house. Right now, so the fireplaces will be placed in the corner, and above that there will be a channel to let the hot air pass through from the room. So this can by the process of convection, the hot air will be rising out of the room. We know that hot air are lighter, they are having lesser density, thereby they rises up right now. And why the convection current here also, the cold winds will be entering the room, right? Then you had the example of exhaust fans as well, right? So exhaust fan actually sucks up all the warm air right now. And one of you mentioned that it also helps to keep the area clean, stops the growth of mold, fungus,
Yes, sir. Yes, sir.
right now. Now let's
Yes.
get to radiation. So the radiation is basically what? It's the process of transfer of heat from a hot body towards a cold body.
Cold body.
Direct. So the interesting thing
You are
here,
lagging.
yeah, am I audible now? Hello.
Yes, sir. Yes, sir. You are audible.
Not
Okay.
you're speaking very fast.
Okay. Okay. I will slow up. I will slow a bit. Okay
No,
now.
no, no. So like, no, not
Okay.
like.
When it lags, then the voice runs
Let's
too
try to
fast.
catch up. Now
Okay.
you're
Okay.
audible.
Hmm. So look here, in the concept of radiation now, we did talk it's a transfer of heat in the form of waves for which a medium is not necessarily required. That is simply
Yes.
called radiation, right? So art
Right.
of conduction, convection, and radiation. Which mode of transmission of heat does not require a medium? Out,
Sir, what are
Mhm.
you? Can you repeat again?
Out of conduction, convection, and radiation. These are the three modes of transfer of heat. Which one actually does not require a medium?
So radiation.
Radiation, obviously. Good.
Sir,
Okay. Yeah.
Because
can
for
you?
radiation, the molecules don't heat up and
Hmm.
when it doesn't transfer heat.
Yeah. Yeah, Abdul.
Yes, sir. Can you give some three examples related to radiation,
Yeah, sure, sure. Okay now.
like
First of
alpha
yeah,
particles?
first of all, let's get to have the core concept of radiation very clear. Look over here. Another important thing about radiation is that now that heat from a hot body to a cold body is traveling without heating the space between the two. Look over here, the space between the two body. Consider the example of this sun that is radiating heat and this house. इनके बीच की जो medium है, the medium that is between the two, the medium does not get heated up. Medium is not heated.
Heated up.
So this is very interesting feature of radiation. Ab now Tasin or Abdul, you guys will say like, son, sir, when I stand outside in the sun, then I feel warm. But then actually you feel warm when sun's rays falls upon your body and thereby your body gets heated up. But the medium, जो हमारा air है, the medium here, or whether yeah, the air over here, the air actually does not becomes heated up. Are you guys able to understand what I'm trying to say?
Yes,
Yes, sir. Yes.
I understood. So basically,
Hmm.
the solid things get heated up, but then the
Very good.
air and the gases don't.
Hmm. Yeah. So the conduction in the solid, there also we see that the solid, the whole medium is getting heated up. In the case of convection, we got to see that liquid medium actually becomes warmer, right? But
Yes,
then
sir.
gaseous medium is will be the exception there. The gaseous medium does not itself becomes warm. right? So talking about the example, like whenever you sit near to the fireplace, so the heat that is
Yes.
traveling towards us, it is by the process of radiation, right now,
Yes,
and
sir.
not due to convection. Always remember that, because we know that air is a bad conductor of heat, right?
Yes,
All
sir.
right. So all this thing we discuss. How does heat reaches directly from a fireplace? Fireplace, why the process of radiation, right now?
Yes, sir.
Okay, right. And like the heat that is actually coming from the sun. When we talk about heat radiation, there are several interesting things in regard to that. Like, what is the speed of light? Yeah,
Um, sir,
anyone?
maybe 3 lakh or like that.
3 lakhs kilometer per second.
Yes, sir.
Speed of light is 3 into 10 raised to the power 8 meter per second, right? So since
Yes.
light is having this speed, so heat
Yes,
that is
sir.
coming from the sun, the speed of the heat radiation will also be the same. Chunki this heat radiation is traveling in the
Sir,
form
we
of
have to memorize
sun's
the
light.
equation given.
No, it's just a extra fact which I'm telling you guys. If you look at the answers, these facts maybe they are not mentioned over there, right?
So,
Okay. And then we know that heat travels in straight lines.
Yes,
I
sir.
mean, light travels in straight lines,
Yes, sir.
right? Now, thereby, in the process of radiation, heat can also travel in straight lines. Okay. And it can travel in all directions. It can travel in all
Travel in order.
directions, right? So if I were to say, like, heat will be only traveling in one direction while in the process of radiation, that will not be
No,
true.
no.
Because
Every
if I
direction.
were to sit in different corner of the room, there, how that person also receives the warmth. No matter in which corner of the room you will be sitting, you will receive the warmth from the fireplace, right now, because it travels in all the directions, right? Now
Yes, sir.
I have got some of the examples. Okay, before that, radiations are emitted by all the bodies, right? And the rate at which radiations are emitted depends upon various factors. Okay, so whatever body you have in the universe, whether you, whether me, right now, whether you guys, whether me, whether any bodies, whether it's plants or the
Yes.
rocks or the oceans, all the
Yes.
bodies emits radiation, right? Getting
Right,
it?
sir.
So thereby you must have seen like there's a special goggles using which you can actually see how much of heat is being emitted from the body of a person, a body of a animal or any other thing. Yeah. So how much of heat will be radiated from a person's body or from a substance body will actually depend on several factors. Like it will depend upon color and texture of the surface, right? It will also depend upon the surface areas, right? Now, if a body is having a surface area of this much, and if it's another body is having surface area of this much, so obviously the second will be emitting more heat. It will be radiating more heat into the atmosphere. Hope you guys are getting what I'm trying to say,
Yes, sir. Yes, sir. Getting it.
right now.
Yes.
Okay, so these are the things which influences the amount of radiation. Another interesting thing to think of, like, why does a cup of hot tea become cold after some time? Why does it happen?
Sir, I think because of coldness.
sir, it's because of the cold air in the
Hmm.
environment.
Okay, okay, that is also true. But if I were to say, like, out of conduction, convection, and radiation, via which mode the heat of the tea in the cup is lost. It is lost to the environment via which of the three methods? The obvious answer here is what, guys? It's simple now, very simple. Hmm?
No idea,
The,
sir.
the heat from this cup is lost into the environment. Look, first let's eliminate. Let's start eliminating the options. First option is the conduction. Is it possible for the heat to be lost from this cup into the environment by conduction?
Yes, sir.
How come that is true? Conduction में heat always travels in the solid medium ना. ये हमारा air है that is surrounding this cup. So obviously conduction will not be the answer now. Talking about convection, then again convection में हम क्या देखते हैं? Here also the convection currents are inside this cup only. Okay, and you get to see that why the convection heat is rising up. It is rising up. It is rising up. But what
Yes,
you guys know that in the case of radiation, heat travels in the all directions, right? Heat travels in
right.
all direction, and it actually does not require some medium as well. So this hot cup, hot tea actually becomes cold after some time due to the radiation. Getting it now? Okay.
So, because
So
it
with this,
stays in the environment, so the radiation just.
exactly. And here are some of the examples of radiation in our daily life, right? Like the heat emitted by the radiator, right now, and then the transmission of electromagnetic waves through this microwave oven. Look at some of the examples over here. The heat radiator that is installed in the cars, right? So thereby the heat that is lost from the engine, that is also
So
by the
it's
process of
also
radiation.
installed in the heaters that we use in winter.
Hmm. Exactly. That also consists of radiator, right now. This person is fitting the radiator in the house, right?
Yes, sir.
Okay, now. So these are some of the examples of radiation. Okay, in the next class, we will be covering this chapter and then we will begin with a new chapter also. All right, now.
That's it. This is
Only
all.
you guys tell me which chapter shall we begin in the next class, and both of you tell me.
Sir, I think transportation to animals and plants biology.
Okay, what about you, Abdul?
Yes, sir.
Which chapter shall we begin? Transportation